The total number of tokens in the system is based on a total cap on the amount of risk that's allowed in the system divided by a risk per transaction, and the initial assumption is that every transaction has a fixed risk. Now, you can have different token currencies where each currency represents a different risk category. Documents can be fungible within a currency. That means that consumers have a choice, that given a specific token, they can decide which document to use to purchase with this token. And this permits consumers to actually optimize their use of their risk budget. They decide which documents are most valuable to them, and they go off and access it. Now, this has a lot of potential benefits. It incentivizes sharing. It maximizes the utility since consumers are managing the token use. It bounds total system risk. And this report is actually a very worthwhile read. If this problem is of interest to you, I would strongly recommend reading that report. It's food for thought. Now, another approach that's been proposed is extending label-based policies to deal with risks and benefits. So in the current MLS framework, what you have security levels that represent essentially risk levels. The classification levels of documents represent how risky is it if this document, or what would be the impact if this document got into the wrong hands. The clearance levels of people represent their trust level. How risky is it to give this document to this person? In other words, how likely is it that this document would give this person would give the document to a bad person? Now, in this system, what you have labels that represent both risk levels, which are the columns, and the benefit levels, which are the rows. The organization owning the asset determines the risk level. How risky is it if this document got into the bad hands? The consumer actually determines the benefits to them, and the policy maker determines which one of the squares is permissible. Now, at every security level of a person, you would have a different set of diagrams, and the policy maker, by coloring in the right squares, would change the policy. And what this permits you to do is to align release decisions with mission needs. But there is, of course, the question of how do you convert this into a set of release guidelines, a set of rules that people can use to actually manage this. Another proposal that's been published is an access control model that balances risks and benefits of transactions. And the basic distinction between this work and the JSON work is that in the JSON work, they capped the total risk and they tried to maximize sharing up to that cap. In this work, what's done is the argument is that as long as a transaction gives you more benefits than risks, as long as it increases your total system benefit, you should allow it. And there is no cap on the total risk. Now, so far I've been talking about managing risks and benefits between two participants and looking at individual sharing transactions and deciding whether or not to allow it. Within this community view, the second approach that we are taking is to say that when you want to share information, you're not sharing it because the particular recipient needs it. You're sharing it because what they're trying to accomplish is important. And so even though a particular sharing transaction is disallowed, there may be other sharing transactions that can accomplish the same benefit that are allowed. So that was the basis behind this approach, that if CDC is trying to decide should they share the sensitive information with firefighter Bob, they may feel that firefighter Bob is not trusted for this information. But rather than just saying no, they can do other things. They can, for instance, push the data to somebody else. They can push it to the fire chief. Let the fire chief take the appropriate action to save lives. They can redirect this access request to some override authority who temporarily gives Bob the authority to read this information. Or they can send both the data and the request to somebody on the field, maybe a police officer or some other trusted entity who's on the field, who can make the on-the-spot decision, should they give it to Bob or not. So the point over here is that the access control policy no longer is trying to decide should a particular sharing transaction be allowed. They're asking which of a set of sharing transactions should be allowed. Now, the third part of this picture is the notion of sharing obligations, that when you share data, it typically comes with a set of obligations. And these obligations essentially manage the risks and benefits of sharing. So the point is that when you share information, the risks and benefits are not incurred at that point. They happen after the fact, when the person uses the data, when they disclose it to the enemy, and obligations are essentially constraints on future behavior of participants. So for instance, if CDC sends the sensitive information to Alice, who happens to be the fire chief in this case, there could be a set of obligations that get generated, that Alice should be obligated to use the data. She shouldn't just toss it in the bin. Alice and Bob are obligated to protect the data. CDC is obligated to share regular updates with Bob, because it's important that Bob knows the current situation. Bob is obligated to notify CDC each time he shares it with somebody else, like let's say a police officer, and so on. That there are all these obligations that get created, and we need ways of managing these obligations. So what we've done is we've actually been working on building obligation models. So the basic model is very simple. You have a set of nodes that represent data stores, the principals and local data stores with typed values. The data flows are the edges, which represent data streams between principals. And obligations then represent temporal constraints on events over these data stores and data flows. Now, an important part of obligations is the notion of a penalty, because an obligation may not necessarily be enforceable. And what we want to do is that if an obligation is ever violated, we want to be able to impose penalties on the person violating the obligation. Now, at an abstract level, what one can do is express the kinds of obligations I spoke about in a language, for instance, in a variant of linear temporal logic. So the basic idea is that data store and stream events are expressed as predicates. Obligations are temporal constraints over these events. And the language essentially has a set of actions which give you a set of expressions which give you the source and destination of a sharing channel. And get lock gives you back the value stored in a particular location. There are a set of predicates, which are really the events we are interested in, which are send and receive of messages, and updating the location in a particular store, updating the value in a particular store location. And finally, there are a set of predicates, which are basically extensions of linear temporal logic, which allow us to express properties. So if I was to look at the examples I specified earlier and elaborate on them, the first example is responsive forwarding, that B will send C on a channel every object it receives from A within 24 hours of receiving it. And that predicate over there would allow you to express that. So what it's really saying is that if you receive O on channel C1, then you will send O on channel C2 in the next 24 hours. A non-disclosure agreement takes the form that if B receives an object O from A on channel C1, then B will not send O to any other principal for a year. Usage notification. This was the example I mentioned earlier, that if B gets an object, then for the next 365 days, if B sends it to somebody else, then B will notify A. Recurrence. A will send B the latest update to object O every 24 hours. Privacy. A must delete all personal information about B within 1 year of A storing it. Now, these obligations at the organizational level essentially get expressed in the form of sharing agreements. And the basic idea is that if you have organizations that depend on each other's information, and one organization changes its data representation or its semantics, that breaks software systems. And so what organizations typically do is they construct sharing agreements that encode these obligations, and they then manage these obligations. And so an important part of sharing that's done in the real world is actually to build mechanisms to manage these data sharing agreements. Now, what are the challenges that remain in this problem? The first problem, of course, is that today obligations are specified in English in the real world. They're Word documents. And we really